peak, I wanted it to be large and I wanted to look like a shark fin, basically. And I also wanted it to have like a very high, what's the word I'm looking for? I guess amperage. Because this is basically like, the way that the FID works is that you're generating a flame and then you'll get an electrical signal that is basically equal to the amount of stuff that you're going to have in here. So since it's solvent, it's going to expand a lot and it'll basically saturate the detector. So that's why you want it to be so tall.
What's that red one?
It's saying that it didn't. It's saying that it didn't hit.
Well, was that the one that was empty?
Didn't we have a blank?
Ah, that's right.
Oh, okay.
I didn't think it would actually take a vial. Whatever, that's fine. That's the one that was supposed to be shut down, so that's okay. So basically, here's what the file structure will look like. So here's the folder that we made, 2019-09-16. And then this is the first one that I did with the first heptane. So unfortunately, since this is not like super pure methanol or heptane, you're gonna have a bunch of like junk here. If it's like ultra pure, then this would be flat. Well, almost flat. So this thing at the end is the bleed that I was talking about. So this will go down over time, but like, yeah, this has a bunch of stuff in it. It's not very high concentration because this is like 100, so that's like very little. The problem is that this might eat some of the compounds that we're looking at. So we'll see. Hopefully not. But so yeah, this is also kind of an important aspect of it. Yeah, so see, it looks like a shark fin. That's what you want it to look like. Okay, so let's overlay these. So there's kind of 3 different sectors when you're doing data analysis. So method and run control is what you're going to use to actually like set up your sequence and kind of do the initial, like that's what you actually use to run stuff. And then data analysis is what you can use to actually do your sample stuff. So there's, as I showed on Monday, there's the offline and the online mode. So I would recommend using the offline for your data analysis. So I'm going to actually go ahead and follow my own recommendations and do that. So yeah, there's the integration section, the calibration section, and the signal section. So integration, you can actually go in and like reintegrate your peaks. And then signal is what I use to do the overlay. So then I can kind of see like qualitatively that my calibration came out, because you should see it growing with each one, like your peaks. So we should have free glycerin, mono di-trioluene. So we should have 4 analytes that are growing and then 2 internal standards that should basically be sitting right on top of each other, ideally. So the only other thing that you have to do is that this software it'll sometimes try to like adjust the chromatogram. So these are basically, what do they call them? Time reference points. So you want to delete these because you want it to be like a true representation of the chromatogram sitting on top of each other based off of the time. So that's why you want to delete the time reference point. So I'm going to go through and select all the standards. So basically I'm going to right click here and then I'm going to click left click overlay, And so I have standard 1 selected, so I'm going to do 2, 3, and 4. And so this will have all 4 of them. And then display overlay. Actually, wait a second, that doesn't make sense. Okay, I panicked for a second. I was like, there's 5 standards. What happened in the last one? Okay, there we go. Okay, standard 5. All right, so now we're gonna go through and verify that it worked. So hopefully we're lucky. So yeah, when you do this, you kind of want to do small but wide if you want to have like a deep, if you want to like get into like a deep zoom, because if you kind of just try to do this, then it won't really give you that much like detail. So this looks like this is our butane triol, because this is basically sitting right on top of each other and they're not really growing. This is our monolein. So this is kind of like a conflicting, there's conflicting thought on what to do for stuff that's over on the side. So technically speaking, since these are new calibration standards, you should only see 1 peak. But if they're a little older and they've been sitting for a while, then it's possible that you'll get degradation products. So you kind of just want to like look at this and you want to see that if it's growing or not. So this is like really negligible because it's literally like 20 units high. So we're gonna try to just do this.
What does it mean when they're growing?
So growing as in like you want to see that the peak area is getting bigger between each one. So this is standard 1, 2, 3, 4, 5. Because you want to have a linear calibration curve. So that area, that peak area should be increasing linearly.
Because they have different concentration?
Yeah, because they're all different concentrations.
Okay.
Yeah, because you have different concentrations, which, what did I just do? Oh, I see. Interesting. I get to learn something too today then, because I've literally never had that happen before. I don't know if you should be recording this. That's our monos. And that's the other annoying thing. If you click unzoom, then it'll immediately go all the way out. So you kind of need to be careful with that. So now I'm gonna have to go through and do the thin, or this is probably some random crap peak that we have. So we'll just go through and call this our glycerin. So
how do we know that's the glycerin?
So I know through experience,
okay,
because I know that glycerin is going to have a retention time around 4.5
okay,
or farther. But the other reason that you know is because this is growing between the 5. So each one of these represents a different calibration level. And so you want to see that it's stacked on top of each other. So the reason that I'm not counting this is because for some reason in standard 2, this is the only one that had this, but the other ones didn't. So that means, okay, it's probably something random. Like, let's see if you kind of do this a little bit. So unfortunately, the baseline isn't really flat over here. So there's probably a little bit of contamination that's happening, but hopefully we can get a linear curve out of this. So now I'm just gonna kind of, sure, I can do it that way. Now, here's tricaprin. This is all nice and sitting right on top of each other, so that's good. And then this is di and tri. So Unfortunately, diolein looks like it's split a little bit, but that's not. When you're looking for diglycerides in a regular biodiesel, they're going to be in a doublet. So that's normal.
Doublet meaning 2 peaks?
Yeah, it'll just be like 2 little humps. So you'll see like a little hump and then a big hump. So that's kind of what it'll look like. You'll see two sets of little hump, big hump.
Why do they have 2 different retention points?
So it's because it's not all one compound. It's like probably an isomer and then the not and then like the other regular compound. That's possible that that kind of is an explanation of why they have really close retention times, is that there's probably isomers of each other. Because like for instance, let's say that you're doing a GC analysis on something that's like really glyceride heavy, then you'll get 3 sets of tris, 3 sets of dis, and 3 sets of monos. Because you'll get C16, C17, and C18 of all 3. That's not going to really happen most often because you're going to have a really highly reacted sample. And so from there, it'll most likely be, and then let's say you distill it even after that, then you're not even going to have any dis or tris. So, for instance. Okay, and then this one right here is the tris, so it looks like it's possible that it'll work. Now we're going to have to just kind of do the work to get it done. So, I don't necessarily know how beneficial it'll be to like go through like the entire calibration together. I mean, you guys tell me if it's like, if you think it's gonna be too much. But for now, we have we had our layover, so now we know that that's gonna go. So I'm gonna start with the largest standard and I'm gonna start integrating it. So basically what my goal here is that I want the starting retention time and ending retention time to be the same for every single compound. Oh yeah, I should be wearing safety glasses. Okay, so this is the manual integration button. So you'll basically take this and then that's an example of what not to do. So yeah, you need to be really careful about what buttons you click. So since I want to zoom into here, I'm just gonna do that so I can see it, and then I will click this button. Because basically as soon as I go from here until here, then that will determine like the integration time. So I'm gonna just kind of look at it even closer, and it looks like that's not really the best place to stop, so I'm actually gonna redo that. I'm kind of like anal retentive when it comes to this, so I'm like really specific. You will kind of find your own level of like how intense you want to be about it. But basically when you integrate, you want it to be valley to valley, so you want it to be like as much of a flat point as possible from both sides. So it doesn't, there's conflicting ideas about if you need to follow the baseline or not. So if you think that the area that is being represented there is contributing to the actual concentration, then for instance you would make this like a step. So you would basically make this a flat line from here to here, and then there would be like a little bit of a hump here. But since I overlaid it in the before and I saw that it was really wavy in that region, I'm just gonna go from here to here. So that's like kind of an important distinction that you have to make. Now hopefully, since, I mean, I don't know, it kind of depends if Dr. Williams wants you guys to start doing like in-process biodiesel or not, but if all you're going to be doing is finished product, it's not going to be, there's going to be like very little differentiation. It's all going to look the same.
Yep.
So it'll be fine.
So
Okay.
it gives you the area.
Yeah, it'll give me the area, but what I want to do right now is basically I'm going to integrate all of these, and then I'm going to go to the calibration table, and then I'm going to have it import all of this. And then it'll basically, you'll set the calibration window for all of the compounds, and then it'll pull everything in. And then you'll see if it's linear or not, basically. So I'm not going to mess with the butane triol because whatever. That's not going to really change. So I'm going to go ahead and just make this one peak just to see.
Where do you read the results of this integration?
Well, there's a couple places. So we'll see if this is actually going to be viable or not, or if we don't want to do it that way. Yeah, I don't think I'm going to really be able to get this to be like, because you don't want the calibration or the integration line to be above the baseline. So I'm actually just gonna. Well, that still looks like garbage, so I'm just gonna redo it anyway. So I'm just gonna call it that. So there's a couple places. So this gives you the retention time. So the retention time of this is 16.116, and then this is the area.
Okay.
So there'll kind of be like multiple. If you do a manual integration, the area will be at a 45-degree angle, and then if it's a regular area, then it'll be at the top next to the retention time. And then another place it'll be is here in this table.
What's the unit for area?
The unit for area is like picoamps times time. So it's kind of not, it doesn't really have a unit. Because it's sort of different. It's basically electrical signal times time. So it doesn't really have a unit per se that like is easily translatable. Because I tried to convert between peak area of one type of GC to peak area of another GC, and then I ended up having to go into like intense electron theory. So I was like, all right, back up. not doing this today. And then I basically got a bunch of really confused like questions from the engineers at Procter & Elmer, because they're like, why are you asking this?
So when you hit integration, it will automatically integrate like all the baselines for you. So you are just using this to like calibrate the base, like the
Well,
the
so
red
it's
line?
basically it'll already have it integrated based off of its like standard settings.
Okay.
And so now I'm going
You're just
through
modifying it.
and I'm modifying it based off of what I see. So the
Okay.
only thing that's kind of concerning me here is that I see a lot of tailing. So like this, for instance, looks kind of wonky to me. So I guess I'm just gonna go from here to here, because here's the thing though, is that it's also kind of based off of perspective. So you could be like, you know, this might look really weird because you're super zoomed in. Because normally, like for instance, see, this peak area is only 823 units.
Okay.
Or area counts, I guess. Sure, we'll call it area counts. So that's not like astronomically high.
So you can integrate two peaks in one?
What do you mean?
Like, shouldn't you be like this and this, like what you just did there?
You can. The reason I'm doing it that way is because the way that when I input it into the method, I want it to be one peak. So I'm only doing that in a specific instance because there's two different ways that it basically does its analysis. So it'll either do a summation of all the peaks that are in the window, or it will do a way where it basically picks the largest peak that's within the window. So that's called like calibrated peak and sum peak. So if it's a calibrated peak, it'll only pick one, but if it's a sum peak, it'll do everything. And so you kind of have to be careful about which one do you do, because for instance the calibrated peak will reference the calibration table and the sum peak will also reference that specific calibrated peak. So you basically, like for instance, like you'll have diolein and then diglycerides will be the sum peak, and that will reference the diglyceride calibration curve. So when you're doing the calibration, you want to make them to where they're one peak because it makes it easier. So yeah, if we get to the point where we feel like this is like overwhelming to do in like one day, then that's perfectly fine because I'm obviously doing this like way slower than I would, so I can actually like explain everything in detail, but it might be kind of overwhelming because this, if I'm saying, is when you're doing the calibration, you want to constantly be clicking this save button because that means that you've actually manually integrated it. Because if you go through and do all of it and don't click save, you click it off, then it's gonna be like, okay, bye. So now we're gonna go through, actually, here, I'm gonna get a piece of paper. Let's see if it'll let me do that.
It's not connected to the printer.
Oh, I don't need it to actually be printed. It should tell me what the starting and ending retention times is for everything, I think. Ah, there we go. Integration events. I think that's what I need. Maybe not. Integration results. Aha! That's what I need. Okay, so this will give me the start and end time, so then I can write this down, and then when I'm doing it for the other ones, I can make sure the start and end time is the same. Or at least try. We'll see if it lets me. Okay, so 4.749 is the free glycerin peak. So this one. So that's 4.710 to 4.846. And then when you're doing regular sample analysis, you obviously don't have to be this anal about it. You basically just do whatever you're gonna have. Okay, so that's that. And then 16.116. So monos is 15 point. Was Dr. Williams supposed to be coming to this or no?
She said she had engineering student council.
Ah. Oh,
She's
free
gonna try, but
free pizza, man. Free pizza and Shasta.
wait. So, what is that you just wrote down?
So I wrote the retention time. I'm writing the starting and ending retention time. So I'm doing it for free glycerin, monoglycerins, diglycerins, and triglycerins. So I'm going to use this, so then when I do the other ones, I can basically mimic the same retention times that I had before. Because I basically want the retention times to be the same across all of the calibration standards.
Okay.
You know that these are similar retention times because of experience or
Well, so the standards are all the same, they just have different concentrations. So they're all pre-mixed. And so they're basically, yeah, they're all going to be the same thing, just different concentrations. And then, yeah, when you're doing an unknown sample, you know that the monoglycerin, the monoglycerides will be in that region. If you look at the end of the ASTM D6584 standard, it'll have a sample chromatogram. And then that'll give you like all three monos, the two dyes, and the two tris that will mostly be visible in a regular invisible light. Yeah. Really? And out here, there's really nothing except for the stuff that we're looking for. So then I went, and then this is the retention time. So I know that this is the dye, and then this is the try.
Okay.
And so then I wrote down those retention times, and then I went here, and then this is like the averaged retention time, because it basically gives you the like time at the crest of the peak. And so that's what I used. And then of course the last one's on a separate page because Agilent hates us. I wish that there was like a way that this could be like projected onto like a bigger screen, and then we could all just be like sitting instead of me like sitting here and you all standing. The amperage times seconds. So, because it's basically like the height times that. So I kind of realized that this might be a lot to do in like one sitting. So we might need to split this up.
Okay.
But I'll kind of let you all dictate how when you hit a saturation point, then we can go from there.
What are all the letters there?
I'm not sure what the different types mean.
Okay.
I think normally when you actually have like, when it's actually finally calibrated, it'll basically give you the retention time, it'll give you the area, and then it'll tell you like what internal standard it's like using. But yeah, I'm not sure what these letters mean. Okay, so let's see if this is 4.718 to 4.816 or 812. So that means I'm gonna try to reintegrate that a little bit more. So unfortunately, this one doesn't really give you like a readout. So you basically have to zoom this in until you have enough resolution in your tick marks to be able to actually like get it. So I'm never going to be able to get it out to like 3 units, but if I can get like 4.71 to 4.85, then I'm going to call that good. So that's 4.85, and then this is apparently fine. So I'm just going to go ahead and go from here to like roughly here. So the other thing is that since you're going from a larger concentration to a smaller concentration, when you get to like the smallest peak, you don't necessarily have to like drag it all the way out. If the peak is like tiny, then just integrate the tiny peak.
So this is just for one standard right now?
Yeah, this is for one standard. So I did standard 5, and now this is standard 4. So standard 4 is going to have the 4 compounds and then all the internal standards, but I'm not going to touch the internal standards because those aren't going to really shift very much because that concentration isn't changing. So all I'm going to do here is like verify my integration. So that looks pretty good to me. So I'm going to save it. Now I'm going to go through and do the next one. And then you guys can kind of figure out like what workflow you want to do, because like maybe you want to stockpile and do like a couple samples at once. Oh, I'll ask you this, Dr. Williams.
Uh-huh.
Do you still have a ASTM Crosscheck sample somewhere?
I don't have a cross-check sample. I've got a sample of mine is that came from RNG in those 2 containers that we've been using.
Did it a little under, so I'm going to use the same retention time, but I'm just going to bring it like right up to the baseline, because I don't want to add any additional peak area if I don't have to. So yeah, that's what I'm looking for. I want it to be like straight up to there, straight up to there. I basically want it to look like the baseline is like shooting out of it. Okay.
Are these the smallest peaks right now, or the?
These are the second largest, so I went from biggest to smallest. Because I like to have that one be the representative one, because if you use the smallest one, then it might not cover all of the peak area of the biggest. So yeah, I went from standard 5 to standard down to standard 1. Okay, now we're gonna do this one. So 20.48. So 867 would be like right there, or right here. So that's what it's telling me. So 48 would probably be like here. So that means if you zoom it in through here, it's literally like to here.
So would you recommend going through and getting the start and stop times first and then integrating, or?
Yeah, that's what I would recommend, but I'm gonna just kind of go through this and see, and then I'm gonna overlay them again afterwards through the signal and see if those numbers still made sense. Or I mean, because you can make kind of like an educated guess to be like, is this actually the end of the peak or not? And sometimes it's a little bit of a guess and check. Because unfortunately for some of these, the baseline is a little wonky, so it's a little bit difficult to see like where exactly the peak stops.
Well, I don't know if Daniel explained to you, but basically when you inject the standard, right, you have like a peak that's representative of different regions that are going to be in there, right? But when you inject biodiesel, it won't look anything like this. You're going to have hundreds of peaks that are there, right? But
Yeah.
those hundreds of peaks will come out of the column at about the same time if they're similar to each other. So mono-oleans will come out at the same retention time, but you may have 15 or 20 mono-oleans as opposed to one that's in the standard, right? Diglycerides or whatever will come out in a big cluster, and you may again have 50 or 60 of them as opposed to one of the diglycerides that they give you in the standard, right? So the reason why they're saying you go from this point to this point is because they're giving you the general range of where all of those diglycerides will come out, even though you may have one that's showing up right now in your standard and somewhere in the middle of the range. Okay.
Right, so the thought process is this is going to be the most abundant one for most fuels,
Right.
and then you might have a larger fatty acid profile. So you'll have 3 tris, or 3 monos, 3 dis, 3 tris, theoretically, and then you'll have all this other stuff, which you like. Then you'll get into like plant chemistry if you want to identify what that is. But at this point, we'll just focus on glycerides. Okay, so there's that one. So right now I saved that, so we'll just overlay this so I can show you kind of like why I did it that way. So I deleted the time points because I don't want to see those. now I'm gonna go ahead and overlay standard 4 and standard 5. And then just zoom in, and then it should have the integration times. So like, see, those are pretty much like right on top of each other.
Daniel, can you zoom in on the peaks on the top so they can see?
Yes.
So just pick one of the peaks and zoom in on that. So can you see how it's dropped? So if you overlay 5, 4, 3, 2, 1, they're all, each one of those peaks is going to get smaller and smaller and smaller successively because you decrease the amount of the standard, right, that's in the injection, right? So the standard basically has 500, say 500 ppm, 400 ppm, 300 ppm, 200 ppm, 400 ppm. So those peaks, you can see they're shrinking, right? And you're setting a calibration curve for that specific material in those different standards.
So yeah,
If you're ever doing the calibration and you actually go to the overlay and one looks really weird with an outlier, don't use it in the calibration, right? Because they should be successively smaller and they should be pretty uniform in how they change.
correct. I mean, preferably all 5 of them, because if you want to be like compliant with D6584, it needs to be a 5-point calibration curve.
Right.
But if you're not, then the sky's the limit.
Do you understand what that means when he says the 5-point calibration curve? You think so, yeah? Basically,
But
what's gonna happen is you inject all those standards, and each standard there's 5 different standards that you use for all the different components. So when you go and you make a calibration curve for one of the components, using all 5 of those standards that you've injected, you should get a straight line for the calibration, and that straight line should be, I forget what it says, it was 99.99, Daniel, I forget what the
5 nines.
5 nines, right? So you should be like 99.999 in terms of how that linearity for that calibration curve. If it's not, then you should re-inject your standard because you're not doing a 5-point calibration, right? A 4-point calibration means you're only using 4 of the standards. A 3-point would be only using 3 of the standards. So if you have an outlier, you should re-inject that and try and adjust it so that you can have a 5-point calibration curve. Because the method says that's what's required to actually be satisfying their standard.
So I mean, you can like technically eliminate one, and like I think at REG it was like 3 nines was sufficient. So it just kind of like, it depends. So yeah, see, again, this is kind of like, I want it to be as tight with the baseline as possible. And I also don't want it to go above the baseline, so I went and I did that. So that's my glycerin. So we're halfway through. We have 2 more left after this, and then we can import them. Or then we have to set the windows, and then we can import them.
You should run to the bathroom first.
For you.
I'm good till we're done.
Okay, so we're gonna overlay this and verify that all of our integrations look good before we go forward, so we'll do that. Oh, sorry, you have to switch the signal first.
Use that as a bottle opener. Oh, I'm not very No, I shouldn't fuck with these liquids. It's my cousin's business. They make doors that says doors.
Important. So this is the separate overlay, and then this is the actual like overlay all four. So when you load them in, you want to have this one selected. Because if you do it this way, it'll like freak out. Apparently. Okay, I don't care. Just do it. What? 5.47 here. I'm just gonna zoom in so we can make this a little bit easier to read. There. It's 5.479. This is mono is 16.072. Tricapron is 19.236. So I'm gonna go through and just type all of this. So that's free glycerin. Then this is butane triol, and then that'll be 5.479.
This is where you do the vertical number.
Yeah, this is where you do the vertical number. Yeah. Here, you guys can go ahead. I'm just gonna walk you through this.
Wow, Max, you're doing great. Are the numbers that he's putting in only for the first graph? Like, we have to do them for all?
No, this will update for all of them. So this is just the calibration table of the method. So kind of what you'll have two things. So you'll have the method, which is sort of that's what'll tell the GC how to do everything, and then the sequence will have the specific data that is attributed to each sample.
Mm-hmm.
So the only thing that is attributed to the sample is the chromatogram.
So I need you send us the 3 too.
Yep.
And they are
So Dionylian is
20.
yeah.
How do you know that's down?
So we integrated all the areas, right? So all the ones that have the integrated areas will be the calibrated peaks.
And they're going to go in order, Max. So the farthest one to the right, the latest retention time is going to be the triolian, which will be the biggest peak. The
Correct.
one in front of that will be the di, right? And then the monos. And in there, you're going to have tricapron as a standard, butane triol as a standard, and
That's it.
So that's 20.
And then free glycerin.
glycerin is way back.
So this should be this
No,
one.
tricapron is this one, 19.236.
And in the standard, in the ASTM standard, it will tell you where those peaks should show up, so you know which one is which.
Yeah, and then the triolian is 20. Yeah, but yeah, because the column that we chose is specifically a certain polarity. Really, the only difference is I'm gonna give this to you now. Okay, so now we're ready for that. The only difference will be by weight. If you have a more sophisticated column, then it might be by polarity or it might be a bunch of other things. But this column is specifically by weight. Okay, so we're gonna click through, and then we want to see that this blue thing is over our thing that we're looking for. So 4.753, bam. That's there. That's there. That's there. That's there, and that's there. So that's good.
And what that does is when you identify the retention time there, you're basically telling the GC, this is where you should be looking for a peak in this range, right? So you give it a time, and then it gives a window based on criteria that you set. So inside that window, that's where it's looking for that peak to appear.
Correct. Okay, so now the only other thing is we need to make sure that we set these as internal standards, which I think I already did. So internal standard 1, and then tricapron is internal standard 2, and then, okay, it looks like I already set all of that up. So now we're gonna just put all of the areas in. So I'm gonna show you how to do the first one, and then you guys can do the next ones. So this is standard 1, so we're gonna go to calibration, recalibrate, and then I'm going to tell it to do level 1, and then I'm going to say replace, because I don't want it to average, because then it's going to average with 0, and nobody needs that. So you're going to click OK, and now you basically just click through. Well, you click save, and then you'll click through and kind of do that. So I'll just do that. it's doing that thing again. Okay, I'm just gonna try it. Level 2, replace. Yeah, I don't know why the software is freaking out. So we're just gonna try it. And then after this, we need to go and find the, I think the box is right there that has all of the amounts in it, and then we'll have to type them.
Really important, this little sheet. Most of the time you open up a box and you like trash everything that's inside of it except for the stuff. Right? This basically has on the sheet, it tells you exactly what the concentration is for each compound in each one of the bottles that they sent you. Right? So this is your standard 1, this is standard 2, standard 3, standard 4, standard 5, and then the two internal standards that they gave you. So what it's going to say is when you're actually putting that stuff in, you're going to type in the exact concentration of each compound that was in each standard, and that's how it creates a calibration curve, right? And then this is basically your sheet that guarantees what the materials are, what their percent purity is, what the sample lot was, all that kind of stuff, so that you can, this is what you use for the calibration.
So we have a couple options here, so you can see that all the areas have been inputted, or input. So I'm just gonna grab that, sorry.
Put in, right?
Put in, inputted, something. Words, or thing. So there's a couple options for how we can do this. I think we can kind of play around and see what numbers it'll spit out if we do it that way. So for now, I'm just gonna kind of put it in as, so basically it has it all listed. So it says glycerol, monoolein, diolein, and triolein. So glycerol is free glycerin, and then mono, di, and tri. So I'm just gonna put it in as the number it says, micrograms per milliliter, because this amount number doesn't, like that delineation doesn't really matter. You just basically want to have it to where the math will work out to where it'll give you ppm. So this will determine how you put in the sample amount. So we're just going to try it this way and see how it works. So this one has 5 micrograms per milliliter of glycerol, and then 50 of mono or 100 of mono. Well, actually, I guess this is just free glycerin, so we're just going to do it that way. Sorry, I misspoke. We're going to go through and put the glycerin for each one. So level 1 was 5, level 2 was 15. And then you have to kind of be careful, because once you put a number in, it will drop if it had a 0 in it. So after we populate all of this, then it will actually, like, then it won't move. Okay, 25... 35, 35, and then 50. Oh, I guess we need to do this one too. So the mono, or the internal standards are, why doesn't it have it listed? 1,000 and 8,000. So I'm just gonna do that. So once we get the numbers in here, then we can kind of worry about order of magnitude, because you can either put this as like 0.1 or, yeah. Okay, so now here's our calibration curve. So we can see that this is not very linear. So for instance, our level 3 is kind of low. So this is, you basically will do your initial calibration, and then you'll go through and then you'll be like, okay, what did I do wrong? So unfortunately, the software is being a little wonky. So right now we'll basically just go through and type everything, and then we might need to go through and like redo some stuff. But I think what would kind of make most sense is to designate another time, or I don't know if you guys want to stay now. I guess we could test one of those fuels, and then when we do that, then we can go through and like fully update the calibration curve, and then check the QC.
Maybe next week.
Yeah, next week.
I don't think we should do the test.
That's fine. I thought so, but I didn't want to make any assumptions. So yeah, let's go through and do this, and then we can kind of look what the curve looks like, and then we can take the opportunity to be like, all right, which ones do we need to check?
Thank you again, Daniel. I really appreciate it.
Of course.
I'm gonna head out. All right, go work on a poster. So
Okay.
if I may email you if I can't get access to the Google Drive, and then you can send me the presentation or whatever. So all right. Thank you all guys very much. Hopefully
All right.
you're learning something.
We are.
All right. I'll have to buy Daniel some pizza or something like that. Have a party at my house or something. All right.
Yeah.
Works for me.
As a thank you.
That's okay. This is not my last involvement.
All right. We'll see y'all.
Yeah, have a good night.
Have a good night.
Okay, so I'm just gonna keep saying. Oh, okay. So this is getting mad at me right now because I haven't updated the internal standard. So since it references the internal standard, it won't actually work until it goes through.
What happens if you press enter? So just clicking.
Let's see.
No, just
Same thing.
Just curious.
Okay, so let's try that. Oh, that one looks pretty linear.
This
So
is.
see, that one's got 4 9s.
This
So that's pretty
is,
good. That's mono.
Hooray!
Got it.
So yeah, hooray, that one works. Free Glycerin's apparently angry, but that doesn't really surprise me. Free Glycerin's always angry.
I think they'd be more level-headed.
Well, they have 2 peaks, and one of them is smaller than the other one, so it's
Did you
like...
see a video from Monday?
No, I haven't. I didn't get a chance to look at it yet. It's long, though, so that's exciting. Hopefully that means you'll all still watch it. Okay, that one's pretty good, too. That one's got 4 9s.
This
Nice. Yeah, be excited.
Yeah!
There it is.
Woo! 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 Yeah, get this in the video. Woo!
Sounds like a little.
This is what happens after Dr. Williams leaves.
I bet it's gonna be mad at you. Oh wow, never mind. That's
No.
pretty.
All right.
3 9s.
Wow.
Yeah, that one could be a little. That one could be a little better, but okay, it's a good start.
Hey, love the hustle. Love the heart.
Good start. So I mean, yeah, the real test is going to be when we can actually go in and do a sample, because then we can go in, refine it,
You're right. You're alright.
shit. After this, we'll need to find a time to run and do the QC. So since you guys have watched me do it, then basically all we'll do is measure out in a SIN file, and then once
Oh,
we
sorry.
go through and do what I showed you during the calibration, and then we'll run it, and then we'll go in, modify the free glycerin, and then do that analysis. And then once that passes, you can start running.
Cool.
So what we did today was identify where the GC should be looking for the peaks.
Yeah, today was basically most of the calibration. The only thing we didn't do was the actual verification. That's the only thing that we need to do now.
How do you do that?
So the verification is the running of the QC. Because once you actually have a sample that you know what it's supposed to be, then you can analyze it. Because if you have like a perfectly linear curve, it might be perfectly linear but off.
Sure.
So you kind of have to verify that with a known sample.
Precise.
But since we have some REG biofuel, we're good to go. Yeah, that's what those 2 gallon jugs are. So do you guys have any questions for me? Did I barrage you too much?
You're pretty neat. Pretty neat.
Pretty neat.
Paul said it best.
So I hope I've been an okay teacher thus far. I guess we'll have a couple more sessions together though, so it'll be good.
You want to smile to the camera at the end.